Okay, so let me share my slides. So once again, welcome you all to this live session 7. So it's already 7:10, and we have waited a lot for other students to join. So I think we can start the session. And apart from that, I really wanted to know your views about this session. So I could read the chat that you guys are doing well in this course, and I think Noel said that time management is an issue. So no problem. We actually upload these videos also on the YouTube so that you guys can get benefits from that also. So okay, let's start. And if there are any questions which you want to ask, please feel free to ask it in the this white box or chat box. Anything you can say. So I can read these questions and we can have a discussion on these questions. So before, let me check. Yeah, everything is going fine. Okay. So once again, welcome you all to the live session 7 of NPTEL of Environmental Impact Assessment. This course is being taught by Professor Harshit Sohan Lakras. He is Assistant Professor in Department of Architecture and Planning, IIT Roorkee. Uh, I am Rohit. I am teaching assistant for this course. So we generally meet on Tuesday from 7 to 9 p.m. and we discuss various assignments of the week. Then we have a one-to-one discussion about different topics or anything you want to ask. Okay, so basically we follow two teaching methodology in this live session. One is basically the discussion on the topic that is being taught in the weekly lectures. So what we do, we solve the assignment questions, and based on those assignment questions, we generally have some topics taken from the live session itself, which can be taught to the linked to the questions and can be discussed during solving those assignment questions. Apart from that, you can always have your doubts raised here, so that doubts you can put it in the chat box, or otherwise you can use the discussion forum to put your queries also. So the first question is, let me take the first question is, what are the effects of air pollutants? So basically, we need to know about this air pollution thing. So air pollution is something that is coming to the air that is harmful to the health of all the not only the biological components, also the non-biological components are also included. So yeah, so what are the effects of air pollution? So generally the question includes that key it causes inflammation, sensitive sensitizes, scar the airways. So basically when you see the lungs through which the particles go into the different travel through the different aorta, alveoli. So yeah, it cause inflammation. More mucus can be generated to stop the particles. Also, can affect the lungs in extreme condition because of the long duration exposure. So there are various risk assessment study also that says that if you have a long exposure to the air pollution, then yeah, these can have effects on the lungs also, the functioning of lungs. Various disease like asthma, cancer, lung cancer can be developed based on the uh, exposure of the air pollutants. Third is pollution can pollution here it's written pollution, it should be pollutants. So pollutants can reside permanently in the body. Yeah, actually these air pollution particles, generally these particulate matters of very small size like PM2.5, they can get deposited in the alveoli and they actually block the ability of body to take up the oxygen from the blood. So that is one of the serious issue that is related with the air pollution. Fourth is impact can vary from irritation, serious illness, or even early death in some case. Yeah, this is also correct. So we could see that all the options here are actually correct. So the correct answer is answer C. So we will know more about this air pollution thing after some time. So I put a video here from the Nat Geo, so that explain beautifully the air pollution. So if we get time from this live session, then we will see this video. I have taken this slide from the weekly lectures itself. So what are the effects of air pollution pollutants on the human health? So it can cause similarly the points we discussed in the question, cause inflammation, sensitize, scar the airways, can affect lung in extreme condition due to long exposure. So everything which has been mentioned in the slides were taken from this here itself. This is what I was talking about. The contaminated food and drinks. It not only affect directly the human or human health, but also have indirect effect on the like contamination of foods and drinks also can be a part of air pollution. So this is a study by World Health Organization. Every year, 7 million deaths are due to the exposure of both outdoor and household air pollution. So if you see that not only outdoor air pollution is causing uh, a problem, indoor air pollution is similar, very big issue for to study. So if you see there are kitchens in the houses, and actually kitchens are very much confined spaces, so these air pollution particles, the particulate matters, are actually more and more concentrated in those locations, so that can cause various diseases like lung cancer, chronic acute respiratory diseases also. And one more thing which I wanted to add here is that if you talk about air pollution, it can also there can be natural sources. Another one is artificial sources. Basically, what we generally relate air pollution with is that air pollution is mostly due to the like emissions from vehicles or maybe from construction sites, or so there are various sources like point sources, area sources, line sources that we will find in the slides also. Some of them I have put it in the this weekly live session also. So basically there can be various sources of the air pollution. One is basically artificial or man-made sources. Basically rating not writing artificial, it can be man-made. Okay, but not only man-made sources are actually affecting the air pollution, but also the natural sources like volcanic eruptions. Are part are part of the air pollution also. So there can be natural sources also, there can be man-made sources also. Some of the regional estimates like they have made a regional estimate about different deaths like 2 million deaths in Southeast Asian region, then we have 2 million in Western Pacific, African, then Eastern Mediterranean, European region of Americas. Okay, so these are some of the estimates because World Health Organization study comprehensively about these type of effects of air pollution on the human health. Another thing is that the World Health Organization is actually defined the air pollution like air pollution and contamination of the indoor and outdoor environment by any chemical, physical, biological agent that modifies the natural characteristic of the atmosphere. So this is one of the comprehensive definition of the air pollution. So when you talk about the air pollution, it is contamination not only outdoor but also indoor environment by chemical, physical, and biological agent. So it can be chemical agent also like the gases, various gases, physical agent also like dust particles, biological agents also like generally we have some viruses, bacteria that can travel through the air. That is also can be included in the air pollution. Some of the examples like household combustion fires, industrial facilities, forest fires is one of the natural sources of air pollution. Pollutants of major public health concern include particulate matter, that is one of the major concern of the air pollution, carbon monoxide, ozone, nitrogen dioxide, and sulfur dioxide. The outdoor and indoor air pollution cause respiratory and other diseases and are important sources of morbidity and mortality. Okay. So there are various guidelines and data also like contains critical levels. What are the critical levels of air pollution? So all these things are very important when you try to study the air pollution thing. So there can be I've compiled a list of like different pollutants that actually affect the air pollution. One of them is carbon monoxide. This is basically generated from the incomplete combustion of fuels, primarily from the road transport, like from the vehicles which travel to the road. Then we have carbon dioxide, the gas generated by burning of fossil fuels in the production of electricity or through the fuels in the vehicles also. So if there is complete combustion, so this is from the complete. So always remember this. This is generated by incomplete combustion. This is through the complete combustion. Okay. There are also nitrogen dioxide basically from the combustion of road transport is basically more contributing to the nitrous oxides. Then we have sulfur dioxides, burning of fossil fuel to generate electricity. So generally we have battery sulfurization plants. So if there is sulfur in the fuel, they can come out as a sulfur dioxide. Then we have ammonia. Ammonia primary atmospheric source is from use in agriculture such as manure and fertilizer. So yeah, not only we can blame the industries for the air pollution, but also agriculture is also to be blamed for the air pollution itself. Then we have volatile organic compound naturally by vegetation. Okay, so some of the volatile organic compounds are there. And we have an ozone layer. So ozone in the upper atmosphere is actually beneficial for us, like it seals the UV radiation and protect us from the harmful effects of UV radiation. But in the ground level, it is like one of the major components of smoke. It causes smoke. So some uh, uh, like smoky thing which you see in winter is actually due to ozone. So it is one of the, and it is very harmful for human health also. Then we have persistent organic pollutants. So volatile chemicals released in the atmosphere often from agriculture and industrial elements. So one of the examples which we can give for persistent organic pollutants is generally use of this plastic thing, various plastic seeds or something. They release a lot persistent organic pollutant. Then we have particulate matter. So particulate matter, some of them can be released from the vehicles, some of them can be released from the area social like construction activity. So they are actually very much problematic for the human. Then we have heavy metals region to the atmosphere. One of the heavy metals is mercury, that then released in the burning of fossil fuels. Okay, so mercury, lead, these things are actually to be blamed. So these are one of most common air pollution pollutants which you see or which you study, which are basically monitored. So air pollution impacts on the natural and built environment. So this is what it says, typical view of the what can be the results of the air pollutions. Like there is some generation of particulates. So these particulates actually can deposit on the surface, and then it uh, uh, actually impedes or stops the basic functioning of leaves. So leaves actually die, then it deposit on the plant. So all these things are there. A lot of things are actually affected on the natural environment. Similarly, for man-made environment, also you see these gases are actually carried out. Then we see the acid rain, which actually damage the monuments, home, everything, plant life, pollutes water. So these things are actually when you talk of air pollution, these they are not only located at local area but can be carried to the transboundary also. So that is one of the major concern. Like some of the air pollution is actually occurring in some 500 kilometer away, but the effect can be felt transboundary, 100 kilometer, 200 kilometer, 500 kilometer away. Okay. Now, the second question is state true or false. So let me see if any question. So या नोवेल has asked that सर मेरा एक ऑब्जर्वेशन है, जैसे कि आप देखते हैं ट्रेन में ट्रैवल करते टाइम लार्ज अमाउंट ऑफ प्लास्टिक लोग थ्रो कर देते हैं विंडो से, वो प्लास्टिक ऑल ओवर द ट्रैक रहता है। ओके, उस प्लास्टिक को कैसे कलेक्ट कर सकते हैं एंड इस इशू को गवर्नमेंट तक कैसे पहुंचाए, बिकॉज इट्स अ बिग प्रॉब्लम। Okay, PM consist iron and elements and dust, rights. Yeah, see, iron is not consistent of, like, PM doesn't contains iron, so maybe dust particles have some outer layer, some iron can be deposited on them because iron are pretty small, they can pass through any membranes or something. Okay, so PMs are basically dust particles, some particles which like unburnt hydrocarbons contribute to the PM. Okay, so particulate matters that are actually very small particles that can get trapped into the respiratory system, can cause damage to the respiratory system through various diseases. The most common example of PM is unburnt carbon particles from the vehicle, and from construction industry contributes a lot to the PM. Even the roads, this the dust from the roads are actually contributing a lot to the PM. When you see the source apportionment study, you will look into the results of source apportionment study of various cities in India. You will see that a lot of things, road is actually contributing a lot to the particulate matter. Another thing is that when you throw plastic all over the track, so generally there can be two solution for this. One is that every train compartments has this dustbin. So basically, we can make them more aware, like don't throw these particles. These can get over the track, over the course of time, over the course of degradation, they can be converted to microparticles that can leach into the various environmental or ecosystem through various services. So biomagnification, bioaccumulation can be a problem of this. Otherwise, because these particles, when you throw out from the window, they are actually spread over a large area, so it is not feasible for the reactors also to travel a long distance and collect these particles. But yeah, there can be solutions, there can be technological solutions for that, like when you throw have you seen the waste collection or garbage dumping trucks? So they have a blower type of thing that sucks the plastic or litigant plastics and then collect it in the box. So that can be a solution for that. Okay, otherwise the best solution for waste management is to make people aware of the waste, don't throw it. Okay, so let's move to the next question. So next question says that air pollutants critical levels is defined as concentration of the pollutants in the atmosphere above which direct adverse effects of the receptors such as human beings, plants, ecosystem, materials occur according to the present knowledge. So if you see the pollution critical levels, so definition of the air pollution critical levels, it is basically a concentration of the pollutants above which a direct adverse effects can be seen on the human being, plants, ecosystem. So it is a true statement. Okay, now you need to know what are the critical levels. Okay, so I made some few slides on the critical levels, what are the different critical levels for air pollution to look into. So first you need to understand, okay, what are the air pollutants critical levels. So they are basically concentration of pollutants in the atmosphere above which direct adverse impacts on the receptors. So what can be various receptors like human beings, plants, ecosystems. Okay, may occur according to the this type of present knowledge. Okay, so this is basically typical definition of air pollutant critical levels. Then this is from the APS 2006 okay report. So examples of the critical levels of air pollutants. So if you see a pollutant like NOx, okay, so receptors can be all. Okay, so what we So here the different receptors, human beings, plants, ecosystem or materials. So basically all can be the receptors, human being, plants, animals, everything. Okay. And within a time period of, there is a time period of study that you say a critical level can be this. So annual mean, so it should not be greater than 30 micrograms per meter cube. Okay. So these are the critical levels for different thing, like for NOx annual mean is 30 gram per meter cube, but if you see 24-hour mean, like for the day, then it can be as good as 75 micrograms per meter cube. Similarly for SO2 for crops, it's 30 gram per meter, forest 20 grams per meter cube, then for natural vegetation annual weight 20. Then we have leachings, that's 10 microgram per meter cube. Similarly for ozone, ammonia, you can see. So there are various critical levels which are actually studied, researched, and defined for different receptors and time period. Okay. Now, World Health Organization have global air quality guidelines. So what these guidelines actually mean? So they have actually prepared some guidelines based on this like time period, everything. So NOx, you can see how stringent these guidelines are becoming. The more and more technology is developing, and more power plants are coming into. So these guidelines has to be made more strict, and more focus should be into the technology. Okay, so WHO air quality guidelines, NO2, 40 micrograms per meter cube was in 2005, but after 16 years it was 10 microgram per meter cube. So they have reduced it by to 25% of the actual value. So you can see the stringent PM 2.5 within 60 years they have 50%. Okay, from 10 to 5. Similarly for PM10, so the 2.5 is the particle diameter, 2.5 micrometer. This is 10 micrometer. 25 to 15. Then we have ozone 100. So ozone not much stringent because no more technology is available to capture ozone from the atmosphere. So yeah, within the upcoming decades you will see a reduction in the ozone levels also. So these are basically guidelines which actually provide for the countries to actually achieve the recommended air quality levels in their country. So apart from the WHO, we also have national ambient air quality standards. This is for our country. So WHO is guidelines based on, so generally when a country prepares a guideline, so it basically studies comprehensive different countries guidelines, and WHO guidelines are actually much broader and much more uh, so it is also taken into account when you prepare a quality standards for a country. So India has also prepared a national ambient air quality standards. So these are basically standards for ambient air quality, and they are prepared by Central Pollution Control Boards. Okay, so they are for 12 pollutants. So you can see that sulfur dioxide guidelines for ecologically sensitive area, it's 20 micrograms per meter cube in annual. So if you see the WHO guidelines, it doesn't have sulfur. So let's see NO2 40 to 10. Let's say nitrous dioxide. So government has also taken it to be 40 for industrial, residential, and rural areas. So generally they adapt whatever WHO says. Some of them can be more stringent, some of them can be relaxed also based on the technology available for capturing these uh, pollutants. So these can be very much important, and there is a method of measuring also is given, like for ozone is basically measured by UV photometric method, then chemiluminescence method, chemical methods. So these type of methods are actually benzopyrene particulate phase only. So this is solvent extraction followed by PLC GC analysis. So these are quite advanced methods when you talk about these type of methods for measurements. So these tests are actually quite complex and advanced, and they give a good quality results also. Okay, so is there any questions regarding this? Which instrument is used to measure PM size? Okay, so generally what happens is that key, huh, so there is auto volume sampler also where we get a sample. There are various sensors which measure the PM particles size, everything. And also there are specific instruments which actually collect the PM on some sample. Then we have some, what you say, uh, thermal conductivity type of instruments or something which we have in the lab. I don't remember the name of this instrument. So they generally collect the PM on some cotton or something, the membrane type of structure, and then they analyze the size and the particle distribution, everything. They count the numbers also. Okay. Then there is question 3. Questions 3 is basically a true and false statement. So it says that International Finance Corporation provides performance standards 1. Okay. Provide performance standards 1. It is international benchmark for environmental and social risk management. So yeah, this is actually a true statement. International Finance Corporation provide different standards. So standard 1 is there for environmental social risk management. Then we in the previous slides also we talked about standard 2, that is basically related to labor or something. So there are various standards which are given by the International Finance Corporation. So yeah, this is actually a true statement. Now, International Finance Corporation performance standards. So you can see the first standard for risk management. This is the first. Then you have second standard for labor. Third standard for the resource efficiency. Sorry. Fourth standard for community, then fifth standard for land resettlement, then sixth standard for biodiversity, seventh for indigenous people, eighth for cultural heritage. So you can see the different standards, like they provide international benchmark for identifying and managing environmental and social risk actually. So it's always better to have a standards. Why do we need a standards or performance standard? Because we can compare when we perform something, then we can compare our performance with respect to some benchmarks. So these standards actually provide a benchmark for our to compare our performance with respect to something. Okay. So this is overview of performance standards on the environmental and social sustainability. So this was from the January 1, 2012 report. So uh, I think they are basically strategic commitment to sustainable development. So everything is basically linked to sustainable development, and it is an integral part of IFC approach to risk management. The sustainability framework comprises policy, performance standards, and environmental social sustainability. So there are a lot of things that are actually um, looked into. So whatever how these are actually enforced. So IFC what it does is it is a part of World Bank group. So World Bank is not a type of bank. It comprises of four different entities. So whenever someone reaches IFCs for some finance, so it requires its clients to apply the performance standards to manage environmental social risk and impact so that development opportunities are actually enhanced. So IFC uses sustainability framework along with other strategy, policies, initiatives to drive business activities of the corporation in order to achieve its overall development objectives. Performance standards may also be applied to other by other financial institutions. So it is not limited to IFC only. The different financial institution, while providing the funding to some projects, can also apply some performance standards. So what they do generally, they when they provide a fund to something, like they provide a fund for something like building a power plant, so they say that this should be the labor standard, this should be the resource efficiency. So you let's say they define a resource efficiency that for a coal power plant there should be a resource efficiency of 30% of electricity from coal, overall conversion efficiency. Okay, so based on that, when they provide fund, they say that okay, at least 30% efficiency should be there, this is our performance standards. Okay, so that also this in the sense they all make them an informed choice and give them good uh, representation on what they are funding or something, so they actually know the things which they are funding are actually have a common standards and much more than the standards. Okay, so this is what they do. Now question 4. So before moving to question 4, let me see if there are any questions from the students. No questions. Okay, so before I move to the next slide, I think you guys, if you have any question, please feel free to raise, because uh, if I go on from slide to slide and you guys didn't understand, I think that will be quite difficult for you guys to grab actually. So I think I should please go through these slides. So if you have any question, anything which you want to ask up to the point, up to the question 3 or 4 which I taught, so you guys can please raise your question in the chat box itself. So this is very interesting question. Here you need to match the different impact prediction methodologies or models with the evaluation models. So there are basically numerical dispersion models, then sampling screening models, then we have Gaussian models. So we will know more about these models in upcoming slides. So basically, when you say a numerical dispersion model, this is a model you can calculate how specified emission rates are transformed by the atmospheric process into pollution concentration at different distance from this source or sources of pollution. So basically, it says that they're dispersing into the atmosphere. Okay, so there must be some interaction or transformation that is looked into the numerical dispersion model. Then we have sample screening models also. So basically, in this type of models, assumptions are taken about the behavior of pollutants in the atmosphere. So generally, we take assumption like these particle will interact with this component of the water, like SO2 will interact with water to form something. So they can be used with limited meteorographical inputs, such as minimum and maximum ambient air temperatures and minimum wind speed, with which worst case pollution concentration can be estimated. Okay. So P2, Q3, and then there is Gaussian model. So this model considers pollutant emission spreads outward from a source in expanding plume aligned to the wind direction. So if there is a chimney here and there is some pollution coming out, so it says that it will go on expanding like this. Okay. So if there is this wind direction, then it goes spread like this. So this is Gaussian model. So P2, Q3, and R1 is the correct answer. So the first thing which we'll see is numerical. What is a numerical dispersion model? So basically, through this model, you can calculate how specified emission rates are transformed by the atmospheric processes. So there are various atmospheric processes that uh, interact with the emissions. Okay, into the pollution concentration at different distance from the source or sources of the pollution. So basically, there can be various things that needs to be studied for actually making a good model, like topographical inputs, weather meteorological inputs, everything is there. Okay, the pattern can vary with the atmospheric processes of the dilution and dispersion, and can also be transformed sometimes because of the chemical and photochemical processes. So there can be chemical photochemical process. Photochemical is something related with light. So some reactions are actually photochemical reactions. They uh, actually happens in the form in the presence of light. So models are also used for predicting pollution concentration for emissions from a single point source, and also from emissions from a large number of point sources simultaneously, like ponds, settling tanks, open cast mines, or quarries. So these are type of point sources of pollution. Then the numerical dispersion models are actually into two types: simple screening models, then we have complex advanced models. So this is one of the examples of screening model, where you provide the what are the source type, like point, flare, area, volume. So point source can be which you see ponds or something. Area sources are large areas, like you see a construction site can be a area source. Then we have line source also, like roads are basically line source. You have emission throughout the line, actually not spread out. And we have volume sources like aircraft landing or something. So airport area is basically volume sources of emission. So what is the terrain type, meteorological inputs, everything is there. So this is simple type of screening models which generate the data, and there are different USPA screen 3, then air screen 3. These are basically softwares that develop the spread of the emission of pollutants throughout the area. Then we have pollution principles of air pollution dispersal modeling, like the Gaussian model which I told. So it says that if there is a chimney located here and the pollution generating, so it will be spread out. Okay, and along the direction of wind, and the concentration here will be like this. And as uh, the area increases, the direction of X increases from the chimney. So let's say this is 10 meter, this is 100 meter, this is 500 meter, this is 1000 meter. So more and more spread will be seen in the this emission classifications, emission pollutants, emitted pollutants, and these will be along a center line, along the direction of wind. So this is how the spread you will see. Okay, so this is how these two types of models actually work. So let me see if there are any questions related to this type of models. Okay, no questions. Okay. Then let me ask, if you guys have no questions, then I think I should ask some questions to make the session more interactive one. So, do you guys have identified some sources of air pollution in your area? So you must be residing. Some of you may be residing in towns. Some of you may be residing in cities or villages. So, what are the air pollution sources which you identify in your nearby vicinity or locality, which you see? So you can unmute yourself and answer. Otherwise, you can uh, put the answers in the chat box here also. So let's see what are the different air pollution sources which you identify in your vicinity. Okay, Jyoti is saying कि she's in Delhi, so PM levels are high here. Yeah, PM levels are actually when we see the Delhi case, Delhi presents a unique case for particulate matters and the pollutions. So generally, what happens in Delhi in winters? So there is kind of this stubble burning thing also that contributes a lot to the particulate matters and other harmful gases. Novel is saying transport, cook stove in village. This cook stove thing, this is contributing a lot to the indoor air pollution. Because in what happens in villages, so Jyoti, I will come back to Delhi. We'll discuss this. This is an interesting topic, I think. So basically, what happens in villages, they don't have a proper cook stove, so they make a makeshift type of cook stove on which they cook. So and they generally use biomass or wood for burning. So what happens that these are mud particles which are generated a lot. So most of the females in the villages has got asthma because of this. So more and more research are actually going on to make these cook stove, make the burning of fuel in this cook stove more and more scientific type, like much more combustion should occur, no incomplete combustion should occur. Okay, transport is also a big problem. Yeah. So generally, when you see a transport, basically the vehicles which are coming with new standards like BS6 standard, they are very clean vehicles. Jyoti is saying many people in the city suffer from pollution problems, throat infection, irritation in eyes, headache, besides breathing problems in elders. Yeah. So so we were talking about this Delhi. So stubble burning in the nearby areas is also contributing a lot to the city. One unique thing which I see in Delhi is that it forms a low pressure zone that actually attracts the uh, pollutants from the nearby vicinity areas to Delhi, and then they get trapped, and more smog type of thing is actually seen in Delhi. So I think there was a picture also in the slides where some Humayun tomb or something, Lodi gardens were there, and there was a picture of a clean view and then a smoky view. So yeah, and yeah, these type of problems are actually very much common when you have particulate matters in the air, the throat infection, irritation in eyes, headache, breathing problems. So, apart from this transport, cook stove, and this PM levels, what other sources which you can identify for the air pollution? Dumping yard also contributes to the air pollution. Yes, dumping yard contributes a lot to the air pollution through methane emissions, actually. So generally what happens that we dump our waste to the landfill site or dumping yard, which you can say. So then the degradation starts, then a lot of methane is actually generated, methane, CO2, etc. is generated. Methane is a problematic gas there. And also there are fires in the dumping yard also because of this methane generation. The fire actually contribute to the particulate matter emission also. So on highways we see sulfur and nitrogen dioxide pollutants thanks to diesel vehicles. So like when you see these diesel vehicles or gasoline vehicles, so the newer standards like BS6 standards, they are actually much cleaner than the standards which were followed earlier, like BS2, 3, 4. Then we skipped the BS5 and we went to BS6 because BS6 standards were actually much more cleaner. And this is a myth that diesel vehicles is contributing a lot of pollution than gasoline vehicles. So no, actually the standards are so uniquely defined, uniformly, not uniquely, uniformly defined that the diesel vehicles and is as clean as petrol vehicles. Okay, the emission from diesel vehicles is as clean as petrol vehicles. So this is uh, you cannot say diesel vehicles is pollutant in now the case scenario. But yeah, what happens that most of the vehicles which we see is large trucks. Okay, so these trucks were actually following BS3 standards. So yeah, at that time diesel vehicles were much more polluting than petrol vehicles. So in general we have a view that diesel vehicles has a lot of pollutants, so which in one case is also true, but if you see the current scenario, diesel vehicles and petrol vehicles are contributing the same to the pollution levels. Delhi has limited these vehicles, but in few areas these pollutants prevail. Yeah, quite okay because see, Delhi, I'm not very sure about the heavy vehicles contributing to the pollution of Delhi because Delhi has got good roads in the outer surface area, like some expressways are built through which the heavy vehicles actually pass without crossing the city Delhi. But there are pollutants from the vehicles. Like Delhi has a lot of vehicles because of more and more increase of population. Vehicle fleet is growing actually. Okay, one more thing which you can't identify as a source of pollution is construction sites. They contribute a lot to the particulate matters because of the dust, cement particles, everything. Okay, they really contribute a lot to the pollution. Construction sites. Jyoti is saying, but one feels the pollution whenever diesel vehicles are near. Yeah, that's because Jyoti. Jyoti, what you will see that if there is BS6 vehicle, BS6 diesel vehicles, BS6 petrol vehicles, you can see the new vehicles like you purchase a diesel vehicle of BS6 and then petrol vehicles of DS6. You will see that the you won't feel any pollutants, but if they are old then they will surely you will see dark fumes coming out of their silencer. Then the question from Noel is that can we capture methane from dumping yards and use it as a fuel? So, have you read about landfill gas generation? Something called landfill gas. So Jyoti is saying, yes, sir. Can we capture methane from the livestock and use it as a fuel? Methane is quite a potent fuel. Catching it makes a lot of business sense. So I don't know. See, generally livestocks, the methane which you are talking about, you need to clarify whether you want to. So what happens that like livestock, a lot of livestock actually contribute to the methane emission. So that comes from their stomach or something. So capturing that will be very difficult as of now. But yeah, methane emissions from agriculture or something is also a quite concerned because the agricultural field is also contributing a lot to the methane emissions. So as of now, capturing methane from livestock is actually very difficult. So what they do generally, they don't capture it directly. Whatever the like waste is generated in livestock rearing, they put it in a biogas plant, then it is converted to biogas, which is basically a gas rich in 60% of methane and 40% of CO2. So that is a potential fuel. Okay. And Noel was asking about, can we capture methane from dumping yards? Yeah, not from dumping yards. So there is distinction between dumping yards and uh, landfill sites. Okay. Dumping yards are open ended, so there is a space where you dump your waste. So it's kind of open waste. Landfill sites are actually engineered sites where you put a membrane layer, then you put your waste, then you pack your waste, then you put some leachate collection well, then you put the methane collection well also. So yeah, the various sites in the world have actually successfully utilized these landfill sites to generate methane gas and capture them. Okay. So in I think in landfill gas the methane varies between 45 to 50% or something, and in biogas plants they vary between 50 to 60% or 65%. Okay, so 35 to 40% is CO2 in biogas plants, biogas, and 55 to 65 is methane. But that's opposite in case of landfill gas. More and more less like methane is there like 45 or to 55% or something, 45 to 50%. Okay, and we have a lot of other gases also in landfill gas because sulfur is there, nitrogen is there, so that is also oxidized into various gases which you see in landfill gas collection. Apart from that, any other questions? So I think you guys are asking quite a good question actually. These questions are actually so. Are you guys from environmental background, or do you have interest in environmental type of thing? Because these questions are quite unusual, which I find on this platform. So it's good that you guys are actually reading a lot about this type of emissions, which are coming from different waste and waste materials, which are contributing. So yeah, they are actually also a contributor. If something like if you can't capture methane from a landfill site, that is also air pollution. But if you capture it, then it is a fuel. Okay, you can utilize that as fuel. And basically methane burns very clean with the production of CO2, and CO2 has a greenhouse gas potential of only 1 compared to methane which has 26 or 27. So methane is 27 times more potent greenhouse gas than a CO2. So basically getting a CO2 is much better option than capturing and letting go of methane, which can contribute to greenhouse gas emission also. So okay. So before we move to the next slides, I think we have been here to question 5. So I think we can take a break of 1 or 2 minutes. So this is not a break. So you guys can go through the slides and then ask some other questions also, and then we move forward. Okay, so let me share my screen. Try to solve this question. Okay, then we'll this was a very good this was, I think, from the weekly lecture, the first lecture of week 7, the order effect assessment tool. So there is a tool also, order, how order is actually determined. So based on that, try to solve this question. Hmm. Okay, so yeah, novel is saying landfill is all about scientific way to dump waste. Okay, huh. So, novel, there are two things. One is open dumping of waste that we practice generally. So, there are dump yard sites. So, whatever sites which you see in India is actually not a landfill site. It is a open dump site. Landfills are basically a scientific way of dumping your waste, in which you pack the waste properly and isolate it from the atmosphere or the city or something. Okay, so it's type of isolating the waste itself from the ecosystem. So that is actually a landfill. Did you got the point? Okay. So did you solve the questions? This question number 5. So basically, the question number 5 talks about order. So how do we perceive a smell or something? So perceiving a smell is actually quite what you say, a very difficult thing. So somebody may have perceived smell as something different. Someone may have perceived something different. Someone is very near to the site of smell is actually perceiving it as a more intense than another one who is living far away from site. So there is some FISOL or FIDOL criteria which we use to analyze the various smell or odor effect. Okay, so there is a unit also, ODU or something, that takes defines how the smell is actually. One ODU is defined like 50% of the people has actually sensed the smell or something. Okay, so you can go through the slides to get a good idea about that. Okay, so this is basically risk-based assessment, which is basically where we look at the pathway and receptor. So if this is the pathway and this is the receptor, so then we look into the risk-based type of assessment and then we draw a conclusion about this. Then we have semi-quantitative assessment, which is basically there are tables basically. You see the tables in the weekly lectures also. So based on these tables and the distance and the perception of the order or something, then we predict the order concentration. Okay, and we follow the dispersion modeling, which is basically order concentration are predicted and compared to the benchmark value, which are accepted values, and we compare with that. So there is a benchmark value, then we predict the order concentration, and then we compare that value or something. So that is basically P2, QR, and Q3, and R1 is the correct answer. So order effect assessment methods. So basically predictive methods include risk-based assessment, semi-quantitative assessment, and dispersion model. So all of these are basically predictive methods for order. Now we have question 6, which is basically different types of modeling like ADMS, EPA, Cal 3QHC, Caline 4 modeling are used by the different countries for road traffic air pollution modeling. So yeah, this is true statement. So we'll see this question as you take it from the slides itself. So you just have to know the different models which are actually used for road traffic air pollution modeling. So that's all. You think if you know these type of models are basically used, you can correct this answer very quickly. So road traffic air pollution modeling, line source model. So UKDMS is line source model. So what is example of line source model? USEPA. USEPA is very environment protection agency. It's a proactive agency and quite good in terms of environment. Caline 4 models, then other proprietary models, NY or PTV group, all these things. So what are line source models? Line source. What is a line source? Can you give an example of line source? I think I discussed it in the this live session also. Line source. Can you guys give an example of the line source of pollution, air pollution? Anyone who wants to actually answer about this line source of air pollution? Okay, nobody is saying sorry, sir, no idea. No problem, it's okay. So basically, when you travel on a road, when you drive a vehicle on the road, so you see whatever the emittents will be coming out of your vehicle exhaust is like a line. You will draw a line. So that is basically a line source of pollution. Okay. Then we move to the next question here. So next question, you have to match the surface and groundwater quality is determined by assessing three classes of the attributes. Okay, so there is physical attribute, there is biological attribute, then there is chemical attribute. So chemical attribute, what is physical attributes? So physical attributes can be for surface and groundwater. Okay, like any presence of any particles, free from any particles or something. And biological attributes like what is the uh, presence of germs, bacteria, everything, biological origin. Then we have chemical attributes. Okay, chemical attributes can be like presence of some chemicals or something. So physical attributes is basically natural waters vary in amount of particulate material present in the river typically carry large amount of particulates. This is what we were talking about. Biological attribute is basically are used to describe the presence of microbiological organism and waterborne pathogens. Many of can cause health issues for humans and animals. And we have chemical attributes, the dissolved chemical solutes which originate from atmosphere, soil, or weathering of better. We need to understand what that water is never pure. So these are various attributes. So correct answer is B. So there are various parameters like dissolved solids. Okay, BOD, COD, uh, turbidity, smell, taste. So these are various parameters which are judged for water. Okay, okay. So groundwater surface quality. This has been taken from the slides. Is chemical attribute, physical attribute, biological attribute. Okay. Then we have this question: water quantity assessment desktop study involved catchment boundary area, drainage pattern, and information on the geomorphology such as slope geology, land use, which can be determined from the base map, geological and soil survey maps. So this is a true statement actually, water quantity assessment. So water quantity assessment can be of two types: desktop study and then field study or something. So yeah, desktop study basically involves catchment boundary area and drainage pattern. So this is quite a true statement. And this so there was two type of study: water quantity assessment, then water quality assessment. So desktop study basically involves the catchment boundary area, drainage patterns, information on geomorphology determined from. So this was the statement which is given in the question. Use of digital terrain models is also required for doing water quantity assessment. Procurement of existing flow records estimation through the use of rainfall runoff models is actually also done. Okay. Then we have water quantity assessment field study. So temporary stream gauging to determine flow regime is needed, but this can be expensive. Stream gauging methods, detailed survey data to input to hydraulic methods. So basically, you go to field, you do measurements and all these things. Okay, so this is field desktop study is basically playing with the data. So before we move to the question 9, let us see if there are any questions from you guys. Okay, no question from the students. So no problem. There's nothing to worry about. So if there are any questions, if you want to ask, please feel free to ask. Otherwise, I think there are five. How many questions are left? Five questions are left. So before we move to the question 9, so I think after question 9 and 10, then we will see the video on air pollution. So you guys can feel relaxed about studying. So there are a lot of questions. Then you guys feel like we are solving a lot of questions. So let's see some informative content also and discuss that. So let us first solve this. Question 9. So, match the following group 1 and group 2. So, basically, base flows are generally movement of water between surface, body, and groundwater. Okay. So, this is base flow. Then there is return period, which is basically tells us the chances of same flow of the rain occurring in the year. So, you see the return period calculation based on probability and the time period. Drainage basin approach is basically in this approach catchments are separated by watershed boundary which is natural division line along the highest point of land precipitation that is rain snow and so on. So the correct answer is P2 Q3 and R1. And what is a base flow? So base flow is movement of water between surface body and groundwater referred to as base flow. So if there is surface then there is ponds or something, some of the water will be seep inside and stored in the groundwater. So this is basically a base flow. So base flow contributes to the river flow varies significantly with the geology and topology of the catchment and with season because if there is rocky terrain then movement will be restricted. If there is less water in different seasons, summer season, then also movement will be restricted. The return period or recurrence interval. Return period is the most common way of showing the chances of the flow or rainfall event to reoccur. Okay, it is a statistical analysis based on the measurement historic data based on gauge flow and weather station data. So there's some p1 minus p or something you can see p by 2 or something. So please check the formula in the slides. Okay, let me see if there are any questions. Okay, no questions. So, if there are any questions which you want to ask up till now, please feel free to ask and try to solve this question. So, this is basically a typical question, very easy question. What is the scale? You have to just match the purpose and scale. So, try to look into the slides and see whether which of the answer is correct. So, let me see if you guys have made answer to it. No answer? Okay, no problem. So, any question from these slides which you want to ask? This return period, base flow, question 9, this one, this one. Please feel free to ask about these questions, these slides. Okay, what is the bedrock? So bedrock are basically the lowest level of the strata of soil that uh, can be termed as a foundation block type of rock that provides on the bed. So that's why we call it bedrock. So if you see the soil strata, this is the bedrock. Okay, this thing which you can see is the bedrock. Then we have some coarse fraction, then fine fraction, then humus that constitute a whole soil layer. Okay. Uh, let's move to the question 10 then. Okay, so basically this is quite easy question. So cover large areas as a whole continent. So if you have to cover a very large area, then you have to have a scale which is bigger to. So scale is 1 is to 1 million or 1 is to 250. Okay, 2,50,000. Okay. Regional maps. So regional maps, when you go for regional maps, then we have sorry, this is for wrong. Cover large area, so large area which is the largest 1 is to 20 million. So this is the correct answer. Regional maps is basically 1 is to 1 million. So if there is large area like continent, countries, then we have regions and we have details. When you go for details, then you look for more and more uh, into the area. So scale 1 is to 1000. So correct answer is P1, Q2, R3. So geological map range, this is taken from slides itself. So to cover large areas as whole continent, this is the for regional map. This for details 1 is to 10,000. And from where you can get the geological maps or digital terrain. So these are some of the portals which I put here with web links also, like for India Geological Survey of India. International, you can go to portal.onegeology.org where you can get the various geological and digital terrain models. Okay, so this is what it looks like actually. If you see terrain model or something, so this is how it looks like, the database or something. So this is from one geology portal, US Geological Survey. Okay, one geological portal. This provides for everything for the whole world. So this is how it looks like. India also is not very behind in this type of thing. So Geological Survey of India is there. So they also prepare the maps for India. So there are two types of maps: solid maps. Solid maps show only pre-quaternary rocks, and there are drift maps, so superficial quaternary deposit that have been laid down more recently after being moved by winds, water, or ice. So quaternary rocks are something like which are not much. Pre-quaternary rocks are much not degraded or something. So this is what solid maps show like. Then before moving to question 11. So we have question 11, 12, 13 and 14. So we can move to and see the different, see the video actually for air pollution, which I think is will be quite useful. So Okay, so you saw this video actually. So this was quite a very good video actually, and one of the video which I find interesting is how different cities are actually dealing with tackling with air pollution. So this was also a very good video actually. So greenhouse gases are gases constituents of the atmosphere that absorb and emit radiation at a specific wavelength within the spectrum of infrared radiation emitted by the Earth's atmosphere. So yeah, this is true. So what happens? So infrared radiation gets trapped because of these greenhouse gases, and it heats the Earth. The average heating, there is some average heating of the Earth, average increase of temperatures. So because of these greenhouse gases, the increase in temperature is actually elevated. So those gases constituents of the atmosphere, both natural and anthropogenic, absorb emit radiation at. So okay, so these are the greenhouse gases basically. Okay, primary greenhouse gases. Then you got to match as per the EIA context mitigation. So mitigation is basically human intervention to reduce the sources and enhance the sinks of greenhouse gases. Resilience. So resilience is basically capacity building. So capacity of social, economic, environmental system to cope up with the hazardous events, trends, or disturbance. Okay. Then we have climate change. Any process, activity, or mechanism that removes greenhouse gas aerosol from the atmosphere. Okay. So specific purpose activities for these are actually listed here. So mitigation, human intervention, resilience, capacity of social, and climate change, change in state of the climate that can be identified by changes by mean of availability of properties. So I put some additional contents also like EIA report. You can go through this EIA report. This is how a EIA report actually looks like. So you can go through this. Then some of the EIA relevant documents in India, like list of standards, standard TOR, guidance manuals are actually listed here. So thank you again. Thank you for this wonderful session and your wonderful question which you have asked in this session. So we will meet again on the next Tuesday. And if there are any questions, please feel free to ask me. You can ask your question in the discussion forum, so we can get, everybody can get benefited from your questions. So apart from that, you can also find me at this email address. So if there you have any specific questions, you can also ask me here also. So thank you once again.